Today we'll be learning about unit testing, and more specifically about the unit testing framework in .NET. As part of that, we'll be identifying scenarios that are worthy of unit testing. Before we begin, you'll want to download and install .NET 5.0. You'll also want to download and install Visual Studio Code. I think that the C# extension from Microsoft would also help if you have that on Visual Studio Code. Create a directory for today's exercise, and we'll navigate to it in a terminal instance. Let's create a new .NET unit test project in its own directory. We'll do that by running .NET new ms test, the output directory argument, test. That's just to say, create a new directory called test, put a new project in there that's of the test framework. Then you'll just want to open up Visual Studio Code to that new directory. I'm doing this to the root directory, so you should be able to see test as a folder within that. In Visual Studio Code, let's open the test directory and open unittest1.cs within that. This is going to be our test class. And you'll note at the top, we've got a using declaration for a very specific unit testing framework library. We've got this attribute here, which designates this class as a testing class, and the test method attribute here to decorate this method as a testing method. This test method then becomes functionally a unit test, and you can do things like run test or run all tests. Let's start with one of the aspects of this library, the testing library, assert. You type assert and then a little period so you get IntelliSense. This is telling me a bunch of different methods within assert. So there's quite a bit of things this library offers you to test. Assert is going to say, hey, is this condition met? If it is met, that is a condition to pass the test. If it is not met, that's a condition to fail the test. We say assert is true and we offer it true. We save that and we run that test. You'll see now we've opened the .NET test log in the output window. And it's run that down here. It compiled the code and it said, hey, run all of the tests you can find. It found test method 1 within unit test 1. So this becomes the namespace class method as an identifier, unique identifier for our test. And the outcome of this test was that true is in fact true. We got total tests 1 passed 1. And if we change this to false and save and run that test, you will see scrolling down, it builds it, and it failed. Assert is true failed. Undo that, save again. I've navigated back to the terminal instance, and we want to be in the root directory, so C# unit tests is what I've got my root directory as. And you'll note if I do ls, I see the directory has test in it. And in here, we're going to add a class library, a project that'll contain code we can actually run tests against. So we'll do a .NET new class lib. The output's going to be source. This is just our source code directory. We're going to keep all our secret logic in. So it's gone ahead and added that. And if I do ls, I'll see I have source and test now. That's good. Let's add a reference for the test library onto the source library. We'll do that with .NET add. We'll specify the test directory, the test class or project within that. We'll do a reference to the source, to the project within that. So we're making the test project reference the source project. That way in test, we can call in some of this code and run it. It says it was added, which is a good sign. Back in Visual Studio Code, we have this source directory now, within which we've got a class1.cs. This is the source project, this is a test project. We know the test project now references the source project. We're going to add something to this class here that allows us to test it. So in class 1, let's add a new method. We'll want something that has tangible inputs and outputs. So let's say it's a public string append non-zero. And we'll pass in an input string. I think this method should have something really complex it does, like prepend an input string, and then just return that. So if we do non-zero, here we're returning non-zero, maybe add a space, and we'll add that to the input string. And then for any input string, we should see non-zero plus that input. Now we've navigated back to the unit test class where we're actually writing our tests, and we want to add a new test method so we can test our class one over here. There's a naming convention we'll use. We'll first start with our test method attribute, and then we'll have our public void. Let's name this test based off what it's going to do. So we have a class that we're going to test. Class 1 is the intended target. Within that, we're going to target a specific method. So we named that method prepend non-zero. Double checking that. Prepend non-zero, yep. And we're going to test a specific functionality. So when we give an input, what is the output we expect? We say, given a day, prepends non-zero. And then we can close out that method. One of the organization templates that I like to use when writing unit tests is arrange, act, assert. I'm going to organize my code preemptively by adding some comments in this method that say arrange, act, and assert. And by doing that, I now can just organize my code and it becomes immediately readable to those that hop in here later, including myself. Let's start by arranging those inputs and expected outputs, and we'll also want to spin up an instance of the class that we're going to test. We'll do that here with our input equals and day. Day is what we suggested we were going to give as an input. We're going to do expected. It's equal to, now we know non-zero space day is what we should expect here. And then we'll also have our tested class, so a testable class is equal to a new class 1. And you'll note it doesn't actually know that class 1 exists yet because we haven't referenced source. We're going to add that using declaration. You'll see at the top using src, so we're now using that project. We'll have access to the class. Now we've done our arranging. Our act will actually call the testable method. So since we've got an instance of the testable class, we can say, hey, the result is equal to what happens when we call prepend non-zero with our input. We've got the expected, and this result, this is the actual, right? So we have an expected result and an actual result. And finally, we're going to assert the results. So in this case, we've got two strings. We can say assert r equal. So assert r equal says pass in the expected and the actual, and we'll handle it from here. So if we do expected comma actual, then we can run our test. We scroll down in our test log, we see given day prepend non-zero passed. And that's great. If we did something else, like if we expected it wouldn't add that space, and then we ran it, we should expect something different will pop up. And you'll note that because we did r equal, because that's how we decided to assert, that's the equation, that's what we're asserting, it's actually telling us right here, we expected non-zero day, but what we actually got had a space here. So the error message has a more meaningful result than, for instance, if we did something like assert is true, that these two are equal, right? If this was the case, then we'd just get is true is not true, it's false. So in this case, there's a meaningful improvement to do r equal. So let's revisit the notion of what is a unit test. A unit test typically attempts to verify the functionality of a single unit of work. So given a class method that has some inputs and some measurable outputs, a unit test is aiming to verify the correctness of part of a method without peeking into sort of like private state management, such as like a database. So if this unit test looks like it's particularly small, that's completely appropriate. That's the correct thing to do in unit testing. It'll be incredibly fast, and it won't rely on state management changes or behaviors to be able to peek into specific results that aren't otherwise publicly available. And so you can parallelize that, run a lot of unit tests very quickly, and what you end up testing then is your secret sauce, your business logic, the core logic that makes your app distinguishable. You're not testing infrastructure logic saying, hey, does a database work the way I expect? Or hey, does a data access layer work the way I expect? Typically, those libraries are handled on their own separately by those that are writing them. If you're hand rolling your own, you might have a way to do that. But for the purpose of unit testing, you're typically targeting something like core business logic. As such, this intense business logic of concatenating a string, that's what we targeted for today. And if we had expected exceptions to be handled here, we would test those as a separate output path. It's a tangible, measurable output, and we can give an input to reach that end result. That's the unit to be measured and tested there. Today we covered the basics of unit tests. We wrote a couple of unit tests in the .NET framework, and we ran them. We identified a couple of different scenarios that might be worthy of unit testing, and we talked on the organization framework of Arrange, Act, Assert. If you have additional time, you might check out the documentation of the library itself, the test tools unit testing library. There's a few other interesting tidbits in there, like data row attribute or expected exception attribute, that might be worth your attention. Other than that, you might look at something like clean architecture and read up on that particular architectural approach and where unit testing fits into that. There are links in the description below. Congrats on a non-zero day.